National 5 Chemistry, Unit 3, Chemistry and Society, Metals. A cell is the simplest form of a battery and consists of two different metals joined in a circuit, separated by an electrolyte. An electrolyte is used to complete the circuit and is usually a solution of an ionic compound. This allows charge to flow. The voltage produced in a cell varies as follows. The further apart the two metals are in the electrochemical series, see your data book, the higher the voltage. The higher the concentration of the electrolyte, the higher the voltage. Electrons flow through the wires of the circuit, from the metal higher up the electrochemical series to the one lower down, e.g. zinc would flow to copper. Ions flow in the electrolyte. Displacement reactions. These occur if the solid metal is higher up the electrochemical series than the metal in the salt solution. The metals will then swap places. The metal higher up would rather be in the ionic form, so gives its electrons to the metal in the solution, allowing the metal in the solution to form as metal atoms. Oxidation and reduction. Oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. A redox reaction is one where reduction and oxidation occur at the same time, e.g. displacement reactions, electrolysis, and making electricity in a cell. Redox equations. The number of electrons in the two ion electron equations must be the same, so that they cancel each other out. 1. Zinc as a solid will become zinc 2+ ion, freeing up 2 electrons. The silver as an ion is only a single positively charged ion, so it only requires 1 electron to give you a single silver atom. Therefore, the silver part of the ion equation has to be doubled to make sure that the charges balance. Reactions of metals. With oxygen, magnesium, zinc, iron, copper. With water, potassium, sodium, calcium, magnesium, if the water is hot or the magnesium is hot. With acid, magnesium, aluminium, zinc, iron, nickel, tin, lead. These show an increase in reaction rate. Extractions of metals. Metals are extracted from their ores. This is a reduction process. Metals above aluminium are extracted by electrolysis. Metals between copper and zinc are extracted by heating with carbon or with carbon monoxide. This includes iron and the blast furnace. Metals silver and below can generally be either extracted with heat alone or are often found in nature as lumps of metal, gold nuggets. Extraction of iron is done in a blast furnace. As well as the iron ore, carbon is added, turned into carbon monoxide gas for more efficient extraction, and limestone, which is there to remove the impurities. Corrosion. This is a corrosion reaction where the surface of a metal is turned into a compound. The reaction is oxidation. Rusting is the corrosion of iron. This process can be investigated using peroxide indicator. This turns blue in the presence of Fe2+ ions, which is the first stage in rusting. It will go pink in the presence of OH- ions. Two things are needed for rusting to occur: oxygen, generally from the air, and water, moisture of some type. Rusting can be speeded up by the presence of ions, i.e. salt being present in the water, acid being present in the water, or being fastened to a metal lower in the electrochemical series, so the iron provides electrons to the one lower in the electrochemical series. Preventing corrosion. There are 3 ways. Physical protection. Things like paint, plastic, metal, stops the air and the water get into the metal. Sacrificial protection. A metal higher in the electrochemical series is attached. This is what happens with pipes in the North Sea, where magnesium is attached to the iron pipes. A version of this, which covers both physical protection and sacrificial protection, is galvanizing, where the iron is coated with zinc, a metal higher in the electrochemical series, so this is what will corrode in preference to the iron. The last method is direct electrical protection. Cars are wired so that the negative terminal of the battery goes to the bodywork. This will provide electrons into the bodywork and slow corrosion. In sacrificial protection, the metal higher up gives its electrons to the iron, corroded in preference to the iron. Iron can be covered by another metal by electroplating. It is attached to the negative terminal and dipped in a solution containing ions of the other metal. Galvanizing is the covering of iron by zinc. It can be both electroplated or just painted on, dipped in. This offers both physical and sacrificial protection, as stated earlier, as zinc is higher in the electrochemical series. Tin plating offers only physical protection and would speed up rusting if there is a crack in the tin, but as oxides of oxygen mixing with any food are less invasive than what oxides of zinc would be, this is why tin plating is used on tin cans.